Welcome to the notes for Chapter 3, Section 1, Day 2. Today we're continuing to look at our trig identities, the reciprocal identities, the quotient identities, and the Pythagorean identities. So, first example, we're looking at the cosine squared of x minus the sine squared of x, and we need to turn it into 1 minus 2 times the sine squared of x. Well, looks like our target has only sines, so I would love to be able to turn that cosine squared into a sine squared. Luckily, one of our trig identities says that since sine squared plus cosine squared equals 1, then the cosine squared part could turn into 1 minus sine squared of x. The minus sine squared of x from up here is still going to be present. And if I have 1 minus a sine squared of x minus another sine squared of x, that means I've really got 1 minus 2 times the sine squared of x. And that was my target. Next example, D, we're looking at turning the secant squared of x plus the cosecant squared of x into the secant squared times the cosecant squared. So this is a little bit of a weird one. Personally, I'm less familiar with and a little bit less comfortable with some of the secant and cosecant rules. So one of the strategies that I use that you might want to is to start by turning everything into terms of sine and cosine. So secant squared, since secant is 1 over cosine, secant squared is 1 over cosine squared. Since cosecant is 1 over sine, then cosecant squared can be 1 over sine squared. What this does is it creates two different fractions, and to add my fractions, I need to create common denominators. My common denominators, well, if this part is cosine squared and that part is sine squared, then I'm just going to need to multiply each fraction by the other one's denominator. So let's turn that into 1 over cosine squared of x times the sine squared of x over the cosine squared of x. Sorry, over the sine squared of x. Sorry, it's got to be the same thing. It's got to be the same idea. Plus 1 over the sine squared of x is missing a cosine, so that's going to be cosine multiplied by cosine squared over cosine squared. And now I have 1 times the sine squared is sine squared of x over cosine squared times sine squared. Plus 1 times the cosine squared is just cosine squared of x over sine squared times cosine squared is actually the same thing as cosine squared times sine squared. And now I have common denominators. So these are both going to be added by adding the tops, where we have sine squared of x plus the cosine squared of x over the cosine squared of x times the sine squared of x. Now what that did for me is that we now have a Pythagorean identity. The sine squared plus the cosine squared can equal 1 over cosine squared times sine squared. And now we can actually separate that out into 1 over the cosine squared of x times 1 over the sine squared of x. And 1 over the cosine squared is really secant squared. And 1 over the sine squared is really the cosecant squared. And again, you might notice that I'm not boxing any final answer because the final answer was given to me at the beginning, a little bit like a geometry proof. It's really the process in the middle that we're looking for. Next example, part E. We have the sine of A over the secant of A minus the cosine of A over the sine of A, and we need to turn that into the opposite of or negative cotangent of A times the cosine squared of A. So let's see here. Secant could be 1 over cosine, and yeah, it's a little bit gross to have sine over 1 over cosine, but I'm only going to leave it that way for a second. And I'll leave this as minus the cosine of A over the sine of A for a second. Now, when you divide by a fraction, you can keep, change, and flip. So we really have the sine of A divided by 1 over the cosine of A, and then minus our cosine over sine. So I'm going to keep that sign. Change that division into multiplication and flip the cosine of A and the 1 minus the cosine of A over the sine of A. But now I don't have common denominators anymore, so I'm going to need to multiply this fraction here by the sine of A on the top and the bottom. So the sine distributes, sine time, or kind of distributes, it's all multiplication. So sine times sine is going to be the sine squared of A, and then it's still times the cosine of A, but now it's all over the regular sine of A, so that we have the same denominator as the cosine of A over the sine of A. Since those are the same denominator, now I can make this into the sine squared of A times the cosine of A minus the cosine of A, and all of that is over the sine of A. And now we start factoring. It looks like somebody already distributed a cosine. So I'm going to undistribute. I'm going to factor out my cosine and turn that into the cosine of A times the sine squared of A minus 1 over the sine of A. Now, the sine squared of A minus 1 isn't exactly one of our rules, but we can change some of what we've got to create a value. Since we know, let's do this down at the bottom, that the sine squared of any angle plus the cosine squared of any angle equals 1, I can subtract 1 from both sides. I'm also going to subtract the cosine squared from both sides. And now, cosines cancel over here, sine and 1's cancel over here, and it looks like the sine squared of an angle can minus 1 can equal the negative version of the cosine squared of that angle. So sine squared of angle minus 1 is really saying I've got the cosine of my angle times the negative version of the cosine of the same angle, all that over the sine of our angle. Sorry, this was the cosine squared. I forgot my squared there. And then if we kind of separate this out a little bit, I can take that negative and move it out to the front. And I can make this into the opposite of the cosine of our angle over the sine of our angle. And it's still kind of getting multiplied by the cosine squared of our angle. And the cosine over sine idea can become cotangent. And it's still negative, and we have the cosine squared of our angle still as well. And that was our target. We have to turn it into the opposite of the cotangent times the cosine squared. Example F, a little bit more similar ideas here. We need to take secant squared of an angle minus 1 over the sine squared of our angle, and we need to change it into the tangent times the secant. Well, if I want to use a tangent idea, well, secant squared minus 1 isn't really a rule, and we're not going to create a new rule, but secant squared by itself is already 1 plus the tangent squared of our angle, and the minus 1 is still hanging out. And all that's still over the sine of the same angle. And we can both, if we're both adding one and subtracting one, those two items will cancel each other out. So we can turn this into the tangent squared of our angle over the sine of our angle. Tangent squared we could express as tangent times tangent. So this could actually be the tangent of an angle over the sine of the same angle times another tangent of that angle. But then tangent could be written as sine over cosine. And what that lets me do is cancel the sine from the bottom of my fraction. So now I have the tangent of an angle times 1 over the cosine of the angle, and 1 over cosine is really secant. So we finally have the tangent of an angle times the secant of the same angle. Just a couple more, or one more. A little bit of a weird one. We need to turn 1 over 1 minus the sine of b, of an angle, minus 1 over 1 plus the sine of an angle into 2 times the secant squared times the sine. Well, the first thing I see here is not common denominators, and there's no way by multiplying to just change that minus into a plus. But I can create common denominators, which will involve a little bit of foiling, the opposite of factoring. So if I have 1 minus sign as this denominator and 1 plus sign as this denominator, then I need to multiply each fraction by the other one's denominator. So I can turn this into 1 over 1 minus the sine of b. Let's throw some parentheses around that. And I can take that fraction and multiply it by 1 plus the sine of b. We still have the minus sign in between the two fractions. And then I have 1 over 1 plus the sine of b, which I will throw some parentheses around because I'm about to multiply this by 1 minus the sine of b on both the top and bottom of the fraction. If you remember some of our factoring rules from algebra, remember anytime you have a number plus a different number times a number minus a different number, we do have a little bit of a shortcut to say it's the first number squared minus the second number squared. And whether it's a single number or the sign of a number, doesn't really matter. We can still use the same rule here. So since I have a plus b times a minus b for both of my denominators, then I can turn that into 1 squared is still 1 minus the sine squared as my denominator for both fractions. And then at the top I have 1 plus the sine of b minus 1 minus the sine of b. Now I can distribute to the 1 and the sine, because technically that minus sign is really a negative 1, and I can distribute that negative 1 so I can get rid of my parentheses here. Oh, sorry about that. My lights went off because I took too long not really moving around. So after I distribute, I'll have 1 plus the sine of b minus 1 plus the sine of b. All that is still over 1 minus the sine squared of b. Again, adding 1 and subtracting 1 will cancel out. So a sine plus another sine means 2 times the sine of b. There's the 2 from our answer. And there's the sine from our answer. We just need a secant squared now. Secant is based on cosine. And remember, since sine squared plus cosine squared equals 1, then 1 minus the sine squared is the same as the cosine squared. Again, we can also separate this into two different fractions and make that, actually we can make it 3 different parts. We can make it 2 over 1 times 1 over the cosine squared times the sine over 1. And 1 over the cosine squared is really the secant squared. So finally, we've turned this into 2 times the secant squared times the sine.